Here I have a problem from the Austin Peay State University 1995 math contest. And it gives us this polynomial here. And it tells us to find the interval, or the two integers, that this thing has a solution. So essentially it's asking us for the two integers that this polynomial here, that I'll box in blue, has a root. And the actual test gives us multiple choice answers, which we can test very easily for. But the way I want to do it is kind of narrow down that range systematically. So first I want to plug -5 into this thing and see what we get. So we have -5 to the fourth minus 5 times 25, that's 5 squared, minus 10 minus 1. And that'll give us 25 squared minus 125 minus 10 minus 1. But 25 squared is a lot bigger than -136. So we'll say that this thing is bigger than 0. And that's all we're going to need for our purposes here. But now let's plug in 0 into this. If we plug 0 in, we get 0 to the fourth minus 5 times 0 squared minus 2 times 0 minus 1. But that's equal to -1, which is less than 0. But by the intermediate value theorem, we know that there is a value that we'll call c, that when c is plugged into this polynomial, we get a root. And by the intermediate value theorem, we know that that c has to be between -5 and 0. So let's keep squeezing this value for c by plugging in different numbers here into this blue box polynomial. So now we're just going to move systematically. I'm just going to plug in -4. So we have -4 to the fourth minus 5 times 16 minus 8 minus 1. And that's going to be 16 squared minus 80 minus 8 minus 1. But 16 squared is 234, but that's still bigger than 0. So we can take our left-hand side of this inequality and change it to -4. We know that c is now between -4 and 0. Let's try -1 and try to decrease the bound going this way. So plugging in -1, we get -1 to the fourth minus 5 times -1 squared minus 2 times -1 minus 1. -1 to the fourth is 1 minus 5 plus 2 minus 1. That is going to be less than 0. Because this thing that I underline in blue, that's going to be equal to -3. But now, because we plugged in -1 and got a negative number back, we can reduce this bound from 0 to -1, and we're slowly closing in on our integer values that c is between. So let's try -3 next. So if we plug in -3, we get -3 to the fourth minus 5 times -3 squared minus 2 times -3 minus 1. So this will be 81, that's 9 squared, minus 45, that's 5 times 9, plus 6 minus 1. So here this number is going to be 46 plus 5, which is 51, but that's clearly bigger than 0. So again, we can decrease this range from -4 to -1 to -3 to -1. So we know c is between -3 and -1. And now we need to know whether c is between -3 and -2 or between -2 and -1. And the only way we can do that is by testing -2. So let's do that. So if we take -2 and we take that to the fourth power, minus 5 times -2 squared, minus 2 times -2 minus 1, we get, this is going to be 16, minus, that's 5 times 4, so 20. That's plus 4, minus 1. So here we get 20 here, -20 here, and minus 1, so this is going to be -1, which is less than 0. But that means that we can take our range from -1 and replace that with a -2. So we know that c must be between -3 and -2. I also want to point out that there are likely more zeros to this polynomial here that I've boxed in blue, and you can find the ranges for those by, instead of using -5 to start, use 5 to start, or some number that's positive on the other side of 0, and slowly decrease your range like we have here, where we got -3 and -2. You'll probably get something that's between two positive numbers. Let me know if you do that, what you get down in the comments below. And that's enough for now.